It's homework time. Yes, happy homework time is here yet again. All right, lesson 12. It's a good one. All right, let's start by jotting our names down at the top of the paper. I will write my name and you write yours. Let's also jot down today's date. Might as well do things right, eh? All right, today you write the actual date, where and when you are in this wide, wild, wonderful world of ours. Our instructions: plot the following points on the number line without measuring. That's important. We're going to figure it out the best we can here. Now I'll tell you, this, in my experience, is a skill that many fourth graders find challenging. This is not one of those easy things. This is going to take a bit of work and a bit of figuring and really working out the logic. It seems so easy, and that's what makes this difficult, is your experience with number lines in the past has been very simplistic. It's just like 1, 2, 3, 4, oh, okay, and you did skip counting on a number line, like 2, 4, 6, 8, or maybe 3 plus 5 is, oh, okay, 8. This is a little different. You'll see how. In fact, our first one just puts us right into it. So we're to plot 2/3 on this number line, which goes from 0 to 1. Okay, and we do have 1/2 marked there, but let's ignore that for the time being. In fact, it would be better if we were to sort of erase that in our minds, and you'll see why. So when we think about 2/3, imagine if this were a rectangle here, right? What would we do to divide that into thirds? Couldn't we draw 2 vertical lines within that rectangle, equally spaced? All right, so again, ignore the 1/2 for a moment. Just let's not think about that. It's a good reference point, but I don't want us to trip over it. So if I were to place 2 lines, and see I'm doing kind of a test run, and you could do the same with your pencil. Again, this is a little trickier than it seems. So I would say, okay, if I'm going to equally space 2 lines in order to create 3 partitions within this imaginary rectangle, which is actually a number line, I could maybe put 1 here, and then another one, say, about here. And notice that these marks here are equidistant from the 1/2. Now we'll bring the 1/2 back into it. And the distance between the 2 marks is about the same, the distance from the second mark to 1 and the first mark to 0. I've done the best I could there. All right, so that means that these would then be thirds. See, so now again, erase the half. 1/3, 2/3, 3/3. See it now? Okay, so this is 1/3, and do label the 1/3. I know you're thinking, well, I don't need to, because trust me, we'll need it in a minute. All right, and then this is 2/3. Okay, and so 2/3 is one of the ones we actually need. So although the instructions don't say so, I'm going to circle that to show like this is one of my actual answers here. Okay, now when we get to 1/6, that actually will be a little bit easier because of what we just did. Because I know that a 1/6 is half of a third, right? It's half the size of a third. So if I take each of these thirds and bisect them, split them in half, I will end up with 6. So this would be 1/6. This is 2/6, also known as 1/3. This is 3/6, also known as 1/2. 4/6, also known as 2/3. And this would be 5/6, which I'll label here. And I'll go back and label. And of course, 1/2 would be 6/6. So this is 1/6 here. And so these are pretty precise. I mean, if I were measuring, they would be even more, but this is pretty good. Now the 4/10 is a little tricky, see, because we've been working with thirds and 6, and that's nice, happy, but to go to tenths with this is a different thing. I'm going to do all my number writing on the bottom of the number line for tenths here, because I want to keep it separate and not end up crowded. So now I mentally have to block out my thirds and 6. So just pretend those aren't there, okay? So I'm going to start with 1/2. That's actually a tenth as well, right? 1/2 times what over what will give me 4 tenths. Can you, or sorry, not 4 tenths, but give me tenths times 5/5, right? So 1/2 times 5/5 is 5 tenths. Okay, so this is 5 tenths. Now, I'm going to spare us both the drudgery of marking out every single tenth along here, because I know that, look, I can go down here and I can say that this is 0 tenths, and the 1 whole is 10 tenths. Can I then place 4 tenths? Well, it's going to be between 0 tenths and 5 tenths. Obviously closer to the 5 tenths side of things, right? So I'm going to put it about yay. Okay, and maybe that's not quite as precise, but it's pretty good. So 4 tenths, there it is. And if you wanted to, you could say 1 tenths, 2 tenths, 3 tenths, 4 tenths. I can kind of imaginary line skip count. 1 tenths, 2 tenths, 3 tenths, 4 tenths, 5 tenths. Okay, so now you use the number line to compare them. This is actually really easy now, because look at 2/3 compared to where 1/2 is. 2/3 is, it's closer to 1, it is greater than, and that's this symbol. 4 tenths compared to 1/6, again, it's closer to 1, it is greater than. 4 tenths is greater than 1/6. All right, I think we did a great job with that. Let's move on to the next one. And number 2 here is actually just pretty well more of the same. In fact, this one has something about it that makes it even a little bit easier, because we're dealing with 4ths, 6ths, and 12ths, and so those work together quite nicely, as you'll see. Okay, so let me start off with, I'm going to start with the 3/4 here, because it's just going to be easier that way. So look, this is 1/2. That means halfway between is 1/4. And halfway between 1/2 and 1 is 3/4. If you're wondering where I got that from, look, 0/4, 1/4, 2/4, equivalent fraction, 3/4, 4/4. You see how that works? So there's 3/4. Okay. And now 2/6. So let's make this into 6. All right, so think about it. If you look back at the one we just did, you will remember that 2/6, here we can even write this out here. Remember, let's set up the division to simplify this. Okay, so what is the largest, remember we did this, what is the largest number that is a factor of both 2 and 6? Well, factors of 2 are 1 and 2. Factors of 6 are 1, 2, 3, and 6. So 2 is the largest number that's a factor of both. And that allows us to simplify this. 2 divided by 2 is 1. 6 divided by 2 is 3. Isn't that helpful to see? Okay, so think about this now in terms of thirds. And you can look back to what we did in number 1. 1/3 is yay abouts, right? So there's 1/3, and I'm going to write that on the bottom. And then 2/3 would be yay abouts. Okay? You see that? So 2/6 equals 1/3, right? So this 1/3 mark here is 2/6. That's it. I hope you see that. Those are equivalent fractions, 1/3 and 2/6. We did all those lessons on equivalent fractions, remember? All right, so now finding 5/12 is not so difficult, because think about 2/6 in terms of twelfths. So let's take that 2/6 and let's try to think about it. We'll set up multiplication this time in terms of twelfths. Well, what's our relating factor here? 6 times what is 12? Well, it's 2. So that means 2/6 times 2/2. 2 times 2 is 4. So 2/6 equals 1/3 equals 4/12. So now, you notice we don't have to mark out, just like above with the tenths, we don't have to mark out this whole number line in twelfths, which would be a little painful to do accurately. So what we can do is say, this is 4/12, So 5/12 is going to be, well, let's think about it. 6/12 would be equal to 1/2, right? Because 6 is half of 12. So now we know two of our data points. We know right here is 4/12, and this is 6/12. What comes right smack dab between them? Our good friend 5/12. Yes. So I'm glad you're here to do this with me, because if you tried to do 5/12 first, it would be a little trickier there. And even with all this math here, you don't really have to write all this out. I wrote this out so you understand what we're doing. But there we go. These are placed with some pretty good accuracy. Now we're just simply in B to select two of these and write a comparison. So let's take these two here. Let's compare 2/6 and 5/12. And look at 2/6. It's closer to 0, right? So it is less than 5/12. Now, how did we plot the points in part A? We don't want to go into a description of how we did each and every one, every single little step. What we basically did was we compared those fractions to the benchmark fractions of 0, 1/2, and 1. And we found their space between those benchmarks, okay? So I plotted the points by comparing them to the benchmark fractions and values, we'll just say, of, well, what did we use? What we were given, right? Of 0, 1/2, and 1. And let me just, give me 30 seconds here to explain what a benchmark is. So if you've ever done any woodworking, which I have, it's great stuff, you might be making shelves. And instead of taking out your ruler and measuring, notice how we were told to do this, and measuring the wood every single time where you're prone to make more error, you just take that piece of wood and put it on your workbench and make a benchmark. This is where I cut the shelves, right here. And so that benchmark isn't going to move. It's not subject to error. It's, there it is, and that's where it stays. And so that's the idea of a benchmark. Like, it gives you that definite point of relative measure, and that's what we're doing here in order to place these. All right, see, this is good stuff, and we are rounding the corner to done. Let's go on to number 3. All right, and number 3, this is more getting into the juice of it, because this is what you really need to be able to do, is to compare fractions. So let's start off. And the brief explanation we can do in various ways. We don't have to write out full sentences or anything. There are different ways of explaining. So 1/2 compared to 1/4. Well, by way of explanation, let's make ourselves a simple number line using, as it says in the instructions, 0, 1/2, and 1. So where does 1/4 fall? Well, 1/4 is here, right? It's between 0 and 1/2. And we know that 3/4 is here. So we're comparing 1/4 and 1/2. Now it's easy to see that 1/2 is closer to 1, and therefore it is greater than 1/4. And we can say 1/2 is closer to 1. That's our explanation. So now let's look at B, and let's make another just very simple number line here. 0, 1/2, 1. Well, 1/2 is already there, great. And now looking for 6/8, let's think about 6/8. Do you notice we can simplify this? When you have two even numbers in a fraction, you can kind of always simplify it, right? So we can think about this in simpler terms, which I think we'll find helpful here. So what is the greatest common factor? What's the largest number that is a factor of both? Well, factors of 6 are 1, 2, 3, and 6, we know. factors of 8 are 1, 2, 4, and 8. The largest of those factors that they have in common is 2. So when we do that, we find 6 divided by 2 is 3, 8 divided by 2 is 4. 3/4. We know where 3/4 is, don't we? This is 3/4, also known as 6/8. Those are equivalent fractions. You see how we're using our knowledge of equivalent fractions here? Isn't it a beautiful day when you use what you learned? Great, so 6/8 then, here it is. It's closer to 1, so it's greater than 1/2. So we can simply say here 6/8 is closer to 1. All right, let's draw another. Now this one's a little trickier. And there are different ways of thinking about this one. Okay, so we'll make our same little number line here, quick and easy number line. 3/4, we know where that is already, right? It's halfway between 1/2 and 1/2, because we just did that on the previous two. 3/5, however. So there are a couple ways we can do this. One is that we can look at this number line and try to split it into 5 equal parts. It's a little tricky though, isn't it? So think about fifths. So here's, let me draw for you, or with you, 2 rectangles of relatively same size. If I were to make this fourths, and I were to make this 1, 2, 3, 4 fifths. Now don't worry about drawing this exactly. Fifths are smaller than fourths. I'm going to write that down. Fifths are smaller than fourths. This is the logic you use to solve ones like this. Okay, fifths are smaller than fourths. So if you have, let's call fourths larger and let's call fifths smaller, if you have 3 larger pieces of cake compared to 3 smaller pieces of cake, obviously which is more? Yes, 3 larger pieces of cake is more than 3 smaller pieces of cake, so we can safely put our greater than. So it's because they have the same numerator, we have the same number of pieces of cake, but we know that fourths are larger than fifths, so we know that because fifths are smaller than fourths, so an equal number of fifths is less. Boom, how's that? You like that? I like that one. And so now let's look at, and I don't even have to place 3/5 on this number line because honestly, you can't just look at that and know exactly where it goes. So we're using a different kind of logic there. All right, so let's draw out a number line to get started on this one. Now here, this one is the trickiest one yet, and we have more of these to do. 0, 1/2, and 1 we're looking at, but we're comparing 4/6 and 9/12. Now what's going to help us here, I believe, the most, is to simplify both of these before we really start to work with them. You can look at 4/6 and probably be at the point now where you can say, the greatest common factor is, well, factors of 4 are 1, 2, and 4. Factors of 6 are 1, 2, 3, and 6. So 2 is the factor that they have in common that's the greatest. And you might not even need to write this out. You might be able to look at 4/6 at this point and know this, just do the math in your head. But 4 divided by 2 is 2, 6 divided by 2 is 3. 4/6 is equal to 2/3. And so we know we did this already. There's 1/3 and there's 2/3, right? So we can safely label this 4/6. So now let's look at 9/12. Now, we want to look for the greatest common factor, the largest number that they both have in common as a factor. Factors of 9 we know are 1, 3, and 9. Any of those 3 numbers also a factor of 12? Well, 1 always is, right? 9 isn't. 3 is though. So we can simplify this 9/12 by dividing by 3/3. So 9 divided by 3 is 3. 12 divided by 3 is 4. Can we safely place 3/4? Yes. So we know that 1/2 is 2/4, right? That's the middle there. And so 3/4 we know is halfway between 1/2 and 1. So there's 3/4, also known as equivalent fraction for 9/12. So this one's a little tricky, isn't it? But it does show you pretty clearly that 4/6 is less than 9/12. All right. Another way to do this one, by the way, would be to put the 4/6, and I'm going to show you this, so suffer through it. We could have the same denominator quite easily here, which makes them easy to compare, because 4/6, we can make that 12ths as well, right? Quite easily. Well, what's the relating factor? 6 times 2 is 12. So multiply 4/6 by 2/2, you get 8/12 compared to 9/12. Obviously, it's less. See, so there are two different ways of doing that. So now our brief explanation is simply that simplifying the fractions shows that 9/12 is closer to 1, or if you like the common denominator method better, you could say finding a common denominator shows that 9/12 is closer to 1. Okay, we got some more of these to do. Let's plug on, yo. All right, so this is all we have left to do, but you see these are pretty involved, so I'm not going to try to speed through this, so don't give me comments complaining that this homework time is too long. I know it is, so do as I do and make yourself a cup of tea. Herbal, always. And let's take our time and do it right, because anything worth doing is worth doing well. Okay, so now on this one, 2/3 compared to 1/4, this is actually a pretty straightforward, easy one. Some of these are easier than others. So if we have 0, 1/2, and 1, we know this. We've done this already. 1/3 and 2/3, there's 2/3. And we know how to do fourths, right? Halfway between 0 and 1/2 is 1/4. So look at that. 2/3 is, okay, so 2/3 is closer to 1. You could also say here, closer to, 1. You could also say here that 1/4 is less than 1/2 and 2/3 is more than 1/2. Compare them to the benchmark of 1/2. Now in this one, 4/5 compared to 8/12, this one's a little trickier, all right? So I think what will help us here, let's do our number line on this one. And if you have a tendency to try to speed through your math, I'm telling you, it's not going to work on this. Like, you can speed through addition, subtraction, multiplication, division, and still get everything right and understand what you're doing. This one, these are like logic puzzles that take a little time to figure out. All right, so let's look at 4/5. So if we were to look at this number line and try to place 4/5, well, I know that 5/5 is 1. So 4/5 is more than 1/2, closer to 1, right? So I could easily just kind of say, well, it's about here-ish, 4/5. Now 8/12, I know that 6/12 is half. You see that? And what would be halfway between? So if this is 1/2 is equal to 6/12, right? Because 6 is half of 12. What would be the midpoint between 6/12 and 12/12? In fact, I'll even write 12/12 here for 1. The midpoint, which I would place right there between 1/2 and 1, would be, well, what's the midpoint between 6 and 12? 3, 6, 9, 12. You see how it's 9 twelfths? Ah, so where's 8 twelfths? Well, it's going to be right before 9 twelfths. Okay, another way of doing this is to simplify 8 twelfths. Your greatest common factor, largest numbers of factor both would be, I'm just going to kind of cruise through this for you, would be 4. So this would simplify to 2/3. When you divide by 4 fourths, you get 2/3. And when you place 2/3, you would actually put it right here. It's an equivalent fraction. So in this case, we're just going to say that, by way of explanation, that 4/5 is closer to 1. We could do a better explanation there, but we'll live with that. On this one, look, you could see this one right off. Look at 3, 6. I'm not even going to draw a number line here. We don't have to. Look at 3, 6. 3 is related to 6. 3 is, yes, half of 6. So this is an equivalent of 1/2. We could do out divided by 3/3 equals 1/2, but we can see quite easily that that's 1/2. Now you remember, well, we'll do our number line. We really don't have to, but I want you to be able to see it just in case. All right, so 0, 1, 1/2. You remember that 1/3 falls here, right? And 2/3 falls here. So here's 1/3. All right, so this is 3, 6, right? 1/2 is equal to 3, 6. So 1/3 is, right, it's less than 1/2, less than 3, 6. So here we'd say 1/3 is closer to 0. Now, ooh, they're giving us a tricky one here. This one, I actually don't want to draw a number line for. So with 7/8 and 3/5, here's the thing. Eighths, think about an eighth compared to a fifth. If you cut that cake into 5 pieces, or you cut that cake into 8 pieces, those eighths are smaller, aren't they? Eighths are smaller than fifths. So if you have 7 of the 8 pieces of cake, you darn well almost have that whole cake, don't you? Whereas if you have 3 of the 5 pieces, yes, they're bigger, but you're missing 2 of those bigger pieces. Whereas with 7/8, you're only missing 1 smaller piece. So 7 out of 8 is more than 3 out of 5, and we can put in parentheses here, it's closer to 1 whole. You see how I said these are logic problems you can't just whip through, you kind of think these through. Now here's a great one. These last two actually both are terrific examples. Okay, so 51/100ths. Whoa, what's up with that? Well, think about this. What would be, doesn't that look like something? Doesn't that make you think of something right off? Think about 50/100ths for a moment. I know it's 51, but think about 50/100ths. Oh, 50 is half of 100. So 51/100ths is equal to 1/2. Okay, look at 5/10. Oh, you know where I'm going with this, don't you? 5/10, well, 5 is half of 10, so 5/10 is equal to 1/2. Now, if we wanted to do the math on that, we would say 5/10 divided by 5/5 equals 1/2. Here we'd say 51/100ths divided by 50/50ths equals 1/2. But we can see now 51/100ths is 100th more than this, isn't it? So this is greater than. And so here we'd say 51 out of 100 is, and we can be very precise here, we could say 1/100th more than, in fact, you note here, this is equal to 50/100ths, right? If we want to put them both in hundredths, more than 50 out of 100. And if you were to put this in terms of money, very useful when you're seeing tenths and hundredths, and especially when we get to decimals, think in terms of money. We'll be doing lots of that. 5 tenths, well, a tenth of a dollar is a dime, right? So 5 dimes is 50 cents. 51 cents, 51 pennies. 51 cents compared to 50 cents. Obviously, 51 cents is more than 50 cents. Similar idea here. Look at 8/14. Oh, that's almost, it's just a little bit more than what? Than a half, isn't it? Because 7/14, 7 is half of 14. You're starting to see those right off, right? Those half equivalents. 7 is half of 14, so 7/14 is equal to 1/2. So that means that 8/14 is a little bit more than a half, isn't it? It's a 14th more. Look at 49 hundredths. Ah, you're seeing it, aren't you? We just did this. We just said that, hey, 50 hundredths equals a half. That means that 49 hundredths is a little bit less than a half, right? And guess what you just wrote? That is your explanation right there. So 8/14 is a little bit more than a half. 49 hundredths is a little bit less than a half. Obviously, 8/14 then is greater than 49 hundredths. Because this is a little bit more than a half. This is a little bit less than a half. Pretty cool, huh? And guess what you've done with your cool self? You completed another homework time. Excellent work. I will see you again next time. It is once again homework time.